Hello! Welcome to Teach Me Maths. My name is Jonathan Hicks. We're doing tree diagrams. Now, tree diagrams are a useful tool in probability to work out certain tricky problems. It helps you track all the possibilities and just makes it a lot easier to work it out. You do need to be familiar with the two key ways of working out probability. I've split those into two different videos which I called the AND law and the OR law videos. So make sure you're familiar with those topics before you come and watch this one. We're going to go back to the same old bag, pulling cubes out of a bag. So in this case, we're going to have a bag, if I just summarize it here, and we're going to have 4 red cubes in this bag. So big R for red, and we'll have 6 yellow cubes. It's important to know how many cubes you've got in the bag altogether. Obviously in this case, we've got 10. So a tree diagram, you have some kind of start point on the left and then it branches out. That's why it's called a tree diagram, because it has lots of branches on. So to start with, you branch into 2 because there are only 2 possible options. When you pull the cube out of the bag, either it's going to be red or it's going to be yellow. There's nothing else that could happen. So that's why you've got 2 branches. If you had 3 possible options, you'd have 3 branches sticking out here. So you have a number of branches depending on how many different things could happen. And then in a kind of vertical column, you list all the possible options that could happen next to each branch. So the first thing that could happen is you could pull out a red cube. And the other thing that could happen is you could pull out a yellow cube. On the branches then, you need to write the probabilities of getting each of those 2 different events, either red or yellow, when you pull it out the back. So in this case, there's 4 red cubes out of 10 altogether, so it's going to be a 4/10 probability of getting red. But you must always cancel down fractions, so in this case 4/10 will cancel down to 2/5, and you just write it on the branch like that. This one then, yellow, 6 yellow cubes out of 10 cubes altogether, so the probability of getting a yellow cube is going to be 6/10 or 3/5 when you cancel it down. So here on that branch is 3/5. Now, one important thing to note here is that when you add up all the probabilities for one set of branches, they must always add up to 1. The branches take account of all the possible options, in this case either red or yellow, and so nothing else could happen. You must either get a red cube or you get a yellow cube. So the total probabilities must add up to 1, because one of these things is guaranteed to happen. Something has to happen because you're pulling the cube out of the bag. It's got to be red or yellow. So in this case you can see 2/5 plus 3/5 adds up to 5/5, so that's 1, so we're fine. Now what we're going to do now is we're going to pull another cube out of the bag, and so you're going to have another set of branches here branching out from our first event. So getting red or yellow was our first event. We're going to have a second event here for again getting red or yellow. But a key question here, something you must identify immediately with these things, is whether or not when you pull the cube out the first time you put it back in, i.e. you replace the cube, or you leave it out, so you don't replace it. And that makes a big difference as to what the probabilities will be. Now it's much easier when you replace the cubes, because the probabilities then don't change. If there are 4 red cubes to start with, you pull one out and put it back in again, there are still 4 red cubes in the bag, so the probabilities are the same. So I'm going to do the example replacing the cubes to start with. We'll work out a probability, and then I'll show you how it works without replacing them, and you'll see the differences. So in this case, we're going to assume we've got a red cube first time, and then we're going to pull a second cube out of the bag. So again, you're going to have 2 branches here. So one branch for red and another branch for yellow. However, if we pulled out a yellow branch the first time, then again, there are 2 possible options. You could either pull out red or yellow on a second time. So you need 2 more branches here, so red or yellow. And you try and line these up vertically, so that's your second event. So that's first thing you pulled out of the bag, and then second thing you pulled out of the bag. Again, you write the probabilities on, but because we're replacing here, you can see that the probabilities aren't going to change. Yeah, the probability of getting a red cube the second time is still going to be 2/5, because whatever you pulled out the first time, you put it back in the bag. So it's going to be 2/5 up here, And then yellow, again, is going to be 3/5 because that hasn't changed. 3/5. So red here, if you pulled out yellow the first time, it's still a 2/5 chance of getting red the second time, and a 3/5 chance of getting yellow the second time as well. All right, so that's your tree diagram for 2 events. Picking a cube out of the bag the first time, and then picking a cube out of the bag the second time. Replacing the cube after the first event. Now we can come on to try and work out some probabilities. So imagine we wanted to work out the probability of getting exactly 1 red cube after pulling 2 cubes out of the bag. So we could either get red the first time and then yellow the second time, or we could get yellow the first time and then red the second time. Those are the 2 options I'm going to look at. So you can't get red twice because we only want to get a red cube once, exactly once. And obviously we can't get a yellow twice because then we don't have any red cubes at all. So in this case, it's the probability of getting red and then yellow, or getting yellow and red. And this is where those and or laws come into play, and they're going to be really important here. So let's just summarize this over here. We want the probability of exactly 1 red cube being pulled out of the bag with 2 attempts here. So that's the probability of, I'll write them out sort of longhand style with, and then we'll work out the do the calculation. So we're going to have the probability of red first time, so that's the probability of red, and yeah, I'll write it here, and then yellow the second time, or is the probability of getting yellow the first time and then the probability of getting red. So it's red and yellow, or yellow and red. Now, if you remember from the and or videos, whenever you see and in probability, it always means times. Whenever you see or, it means add. As long as these events are independent and these are mutually exclusive. Watch the and or law videos for explanations of those terms, but in this case, we're fine. There's no way you can pull a bead out of a cube out of the bag and have it be red and yellow at the same time. So we know that they're mutually exclusive, that's fine. And in terms of being independent, because we're putting the beads back in, the cubes back in the bag, we know the probabilities don't change. So what you got the first time doesn't affect these probabilities. They're still the same. So in this case, we just work out the individual bits. So the probability of getting red is 2/5 on the first time, and so we times by the probability of getting yellow the second time. So red and yellow is 3/5. So it's 2/5 times the 3/5, which goes here. Or, so we add the probability of getting yellow the first time, so that's 3/5, and then, so we times the probability of getting red the second time, so 2/5. Now, what you might want to do here is put brackets around your first event, so your first sort of pair of events, and then the second pair. So either that happens or that happens. It just helps to make it a bit clearer when you're reading it. Strictly speaking, you don't need them because BODMAS says you do multiplication before addition. In any case, you're always going to work this out, and then this out, and then finally you're going to add them together. So we'll do that now. So 2/5 times 3/5, multiply the tops, multiply the bottoms, 2 3s are 6 out of 25, or, because we're adding, again, 3 2s are 6 over 25. So fractions, add the tops, don't change the base numbers, so it's going to be 12 out of 25, and that will be our final answer. So the probability of getting exactly 1 red cube when you pull 2 cubes out of the bag, replacing them after the first one, is 12 over 25. So a little less than half, but that's how you work it out. So you consider your option, and remember if it's something and something you multiply, and then you consider another option, so then again it's that and that. So whenever you see and, you're multiplying, whenever you see or, you're adding. but you just trace through the different possibilities on the tree diagram and it makes it quite easy to work out. Right, we now need to change this so that we can work out the probabilities when you're not replacing the cubes in the back. So give me a minute to rub some of this out and I'll explain how that works. Alright, so I haven't actually changed very much here. The probabilities of getting red the first time and yellow the first time are still the same, because at the start you've got 4 red and 6 yellow cubes in the back. I've only really rubbed out the probabilities of the second event, and these are going to change. So if you get a red first time, you're only going to have 3 red cubes in the back. So the probability of getting a red the second time is going to be 3 out of 9 now, because again you've lost one of the cubes at the back. So it's a 3/9 probability of getting red the second time. Yeah, you've lost a red, so it's 3 reds out of 9, because again you've lost a cube. 3/9 will cancel down to a third, so the probability of getting a red the second time is actually a third. Not as much as it was before, because you've lost the red. Now if you take a red out the first time, the probability of getting a yellow the second time is still going to be 6 here, but now it's out of 9 instead of 10, because you've lost that red cube that you pulled out the first time. So 6/9 probability here, it gives me 2/3 when you cancel it down. Again, notice that these probabilities add up to 1. Right, second branching here. So if you took a yellow bead out, a yellow cube out the first time, the probability of getting a red cube is going to be 4, because you haven't taken any reds out, but again it's going to be out of 9 because you've lost one of the cubes. So 4/9 has got to go here, 4/9. And the probability of getting yellow the second time, well, if you've lost one of the yellow cubes, you've only got 5 left. There are 9 cubes, remember, so it's going to be 5/9 chance of getting a yellow one this time. So that's what the probabilities will look like. Now, if you did this, it is possible to do this with what's called conditional probability, and the formulas for those can get quite complicated. Technically, you see, these two events are not independent, because the second one, the probabilities, depend on what happens the first time. Now, using the tree diagram though makes this a lot easier to work out. You don't need to use all the conditional probability formulae. Because you've worked out all the probabilities separately, you can just use those and treat it as if they're independent with different probabilities. The long and the short of it is, you can do exactly the same thing as before, tracing the different possibilities, so red and then yellow, or yellow and then red. You just need to be careful that you've worked out the probabilities correctly. So as long as you've done that, you should be fine. And that's what makes tree diagrams so good, so useful, because you don't need to worry too much about conditional probability. So if we try and work out the same thing again, the probability of getting exactly 1 red, well again it's the probability of getting red and yellow, or yellow and red. It's just that the actual calculation here is going to be different because all the probabilities for the second event have changed. So if we work it out again, you're going to get red first and then yellow. So red first is 2/5 and yellow is 2/3. So it's 2/5 times 2/3 because it's and. So 2/5 times 2/3, or, so we're adding, our second event is yellow and then red. So the probability of yellow is 3/5 and red is 4/9. So now it's 3/5 times 4/9. So 3/5 times 4/9. Now we multiply the fractions. So you're going to get 4 over 15 here. Plus, now we can cancel here. The 3 cancels with the 9. 3 goes into there once and 3 goes into 9 3 times. Nothing else will cancel, I think, so you're going to get 4/15 here. So actually, because of the way it's worked out, the probability of getting red and then yellow is the same as the probability of getting yellow and then red. That's not always true. It just coincidentally, in this case, it is true. So 4/15 plus 4/15 gives you 8/15 altogether. And that is your final answer. So this time, the probability of getting exactly 1 red is 8/15. So different from what it was before when we were replacing the beads. Obviously, because you're leaving the cubes out of the bag, then the probabilities are changing. So that's how you use tree diagrams Just be very careful about the number of beads or cubes or balls or whatever they are you have left in the bag after the first event. Yeah, if you're taking a red out, you've got one less of those and one less altogether. If you're taking yellow out, you have one less yellow and one less altogether. You can have multiple stages here. So if that was pulling one cube out, that's pulling two cubes out. You could have another event where you're pulling a third cube out. And again, you just branch off from each of those with each of the possibilities. Working out the probabilities though, you just trace through all the options that satisfy whatever the question's asking for, remembering that if it's this and this, you multiply, but if it's then or this and this, the or means add. My name is Jonathan Hicks and you're watching Teach Me Maths. It's going to be 4 out of 10, and so you'd write 4/10 here like a fraction, but you must remember with fractions you should always cancel down, so 4/10 is going to cancel down to 3/5. So on this bit here I'm just going to write 3/5. This branch then, chances, that's not right at all. Let me correct that. 2/5.